Thank you so much. And everyone, I'm so honored to be able to be with you all here today. I'm actually broadcasting live from Vulture's headquarters here in West Palm Beach, Florida. Vulture, based here in West Palm Beach, Florida, has long been a supporter of the Israeli tech ecosystem. As a global independent cloud, we were the first global independent cloud to open our data center in Tel Aviv in May of 2023. I was very honored not only to open that data center in Tel Aviv, but to also ensure that that data center provided availability globally to support the tech ecosystem in Israel of NVIDIA's top of the line GPU, the first cloud provider to offer unfettered access to NVIDIA H100s for training AI models, as well as the GH200 for inferring those models for global production. So I'm very excited to be here today. This also comes on the backs of our recent sponsorship of the AI Summit in Tel Aviv just this past September with Calculus. And we're very excited to continue partnering with Calculus and the AI tech ecosystem by sponsoring a very significant AI summit here in Miami coming up in 2 weeks, where we're trying to unite both the ecosystems of Miami tech with Tel Aviv in order to foster great ties and great unity as we explore a new frontier of innovation through AI. I'm very pleased to be kicking off here today to talk about what we here at Vulture believe is a new 10-year cycle of cloud compute, where each of us has an opportunity to invent new business processes, invent new ways of working, invent and reinvent entire new industries. And we want to do our best here at Vulture to ensure, again, unfettered access to top of the line cloud infrastructure to provide a level playing field to enable the entire Israeli tech ecosystem to be the pioneers of a bright new future powered by AI. I'm here to talk about what that 10-year cycle of cloud compute looks like and what we believe are the core foundational principles for building a new cloud platform for new AI native applications. So let's begin. So, what we believe is as we're entering in 2025, we're moving past the early hype cycle for AI and moving beyond exploring the art of the possible and moving to the science of how to achieve real outcomes and scale new profitable business models. Just last week, I had the pleasure of attending another event in Orlando, just north of me here, which was Gartner's IT Symposium. So, Gartner's IT Symposium, one of the largest events here in North America for CIOs, to talk about the CEO and CIO agenda for the coming year. And just prior to the event, Gartner does a worldwide survey, thousands of CIOs and CEOs to understand the key corporate initiatives for the coming year. And this year, not surprisingly, all IT initiatives were related to growth, as they are pretty much every single year. But two things really stood out in this year's 2025 survey, which was beyond just pure growth. The second priority for CEOs and CIOs was new corporate initiatives related to AI, specifically initiatives around unlocking innovation and new business models, leveraging custom-built AI models, or leveraging AI from new third-party partners. That again speaks to the significant opportunity that exists to reinvent entire new industries by leveraging core foundational AI services or bespoke, customized, tailored AI services to support key operational workflows for both employees and customers in specific vertical industries. The number two priority out of every CEO essentially on the planet tied to all of their strategic growth initiatives. One of the interesting priorities that crept onto the priority list this year, which hadn't previously been seen since the start of the pandemic in late 2020, when they did the survey following COVID, was risk mitigation, which is really not too surprising because as CEOs and CIOs are looking to foster growth, specifically through leveraging AI and reinventing entire new business processes and entire new business models, one of the core concerns they have is making certain that they have the proper compliance framework for both their data as well as the application of that data to deliver those new business services, and they need to do it up front. So, with this in mind, for us here at Vultr, it really undergirded how substantial the transformation we expect to be in 2025 when we're looking at cloud strategies for enterprises to be able to unlock growth tied to new AI initiatives with a secure, compliant foundation to make sure it can be trusted, to make sure it can be safe. Now, I go back in industry a really long time. So I'm a little older than I may look, which is why you'll see me drinking coffee here at 4 a.m. in the morning for the kickoff of today's keynote. Each 10-year cycle that we embark on, we have seen in the past. And there's always lessons learned from each 10-year cycle in compute that we can carry forward to help instruct us what we should look for in the next 10-year cycle. So without going all the way back in time, I'll go back to the relevant start of the modern era of compute, which largely speaking began in 2001 with the global adoption of web application architectures. So I was part of this cycle. Back in 1996, I co-founded a company called Interwoven to invent a new global infrastructure to enable startups and enterprises to move their business to the web. That was our mantra, move your business to the web, and to get rid of centralized client server applications and move to a more distributed compute model where you could actually build and deploy a web application using web standards, an application server, and you could actually distribute code and content to have a more distributed compute infrastructure for your servers, as well as more globally accessible application access for your clients leveraging a standard web browser. So again, back in those days, you had, your data centers all on-prem, essentially in your physical facilities where your employees were largely speaking working, and everyone was connected on the LAN, the WAN, for their desktop computers. And then with the web application architecture, we had the ability to start putting our server infrastructure in colo facilities and start getting it out of one centralized location and start distributing code and content to a London, to a Tel Aviv, to a Singapore, and then of course build those applications in such a way that people could access them whether they're at home or whether they were at work using a simple web browser. Now, this 10-year cycle, again, began in 2001 and largely took us all the way through the mobile social revolution as well, all the way to 2012, when we began a new cycle of, modern core compute. And this was the debut of cloud platforms and the move to more of a cloud native application architectural style. This architectural style is the architectural style that's carried us all the way forward here to the AI revolution and essentially is a cycle that we're ending now. And in this cloud native, application architectural style revolution, businesses took one step further, moving from, colo data centers where they had distributed server infrastructure via a web application to deliver to a stateless client, via the browser. But then they went one step further and then started building natively in a third-party cloud provider using third-party provided cloud services to provide some of the core infrastructure elements needed to extend the distribution of compute all the way to the edge. This was the original purpose of cloud architectures when people started adopting EC2 and S3, extended and accelerated through the adoption of the open source Kubernetes framework, and then carried us all the way forward to the end of the cycle with the debut of serverless computing options tied to enabling developers to be maximally productive, to simply write a function, press go, and have global availability. Okay. So now we're at this next compute cycle where we're moving from primarily a CPU based cloud architecture and compute architecture to a new architecture where the GPU becomes at the forefront of delivering value tied to unlocking the power of our internal proprietary data to deliver contextualized, personalized digital experiences and services to both our customers and to our employees. And in the early hype cycle of AI, what we've seen is this mad rush for everyone to secure access to GPUs, specifically the NVIDIA H100 GPU, for purposes of training and exploring the art of the possible. And in this early hype market, it didn't matter where you could get access to the H100, who you could get access for. You just simply needed access to begin training to understand what you might need to start prioritizing in terms of key corporate initiatives going into 2025. And in that early hype, where people were just looking for early access to H100, again, people weren't thinking about the global application architecture of what's to come in terms of how do we have distributed compute power, leveraging all of our distributed data, and do so in a safe, trusted, compliant way. But as we know from Gartner's global CIO CEO survey, as people look to unlock growth, it's all tied to new AI services that have to be globally distributed. They have to be globally available, just like every other web application or cloud native application we've ever built. And it has to be built up front with the foundation of trust. So, what's exciting about this talk here today is let's invent the future together. The future is bold, the future is bright, and we personally believe that the future would be powered by amazing innovation coming out of the Israeli tech ecosystem. And we couldn't be more proud to kick off this keynote today to think about this bright, bold new future where pioneers such as all of you in this audience can reinvent the future and reinvent the future with new possibilities we've never been able to explore before. So what are these five core tenets of a modern, cloud platform to unlock AI native applications? And the five key principles that we'll walk through here today, and hopefully have a ton of questions, are the following. First and foremost, it needs to be based on composable infrastructure. We'll talk about composability and what that means and what are some of the things that composability gets you that I'll take a lesson learned from the current era of cloud compute. It's all about enabling that hybrid multi-cloud. so that again, you can unlock innovation across an ecosystem of cloud service providers and very importantly, unlock the power of your private data in a safe, secure way. It's about a serverless infrastructure, not for functions. That's important, that's necessary, but it's not sufficient. It's about a serverless infrastructure for AI. Now, if that intrigues you, just wait, we will get there. And of course, as we've all learned over the course of the past maybe 12 months specifically, to truly unlock the power of AI, we do need to augment AI, enable our applications in order to ensure that we do deliver that hyper contextualized response. So we're going to tell you a little secret about how to enable turnkey RAG uh, toward the conclusion of today's talk. And last and most important, and the thing that we can never forget, is in tech, we have historically had philosophy, at least coming out of Silicon Valley, where I spent the first, 25 years of my career on move fast and break things. The whole idea was if you weren't breaking something, you weren't being disruptive enough and you weren't moving fast enough. Unfortunately, we have to have a new mantra in this day and age of AI. It's move fast and make things and make them work correctly, and make sure that they're trusted. So let's move forward fast and make things, and let's put compliance and trust and safety at the core of the mission and not an afterthought. Because unfortunately, in this day and age, if we move fast and break things, there might be things that we might not be able to put together again correctly with AI. So let's make sure we build the foundation properly this time around. So let's jump into it. So let's talk about composable infrastructure. And again, this is taking lessons learned from the prior epoch that's just ending now of cloud computing and carrying it forward in a new way to this day and age of AI. Now, again, having been in the industry a long time, one of the things that we saw in this last era of cloud compute is as startups and enterprises were rebuilding their application stacks around cloud native principles with mass adoption of Kubernetes and a wholesale movement to building new microservices that they could containerize and run on a Kubernetes backplane. Um, what people discovered is that they needed to have a set of guiding architectural principles for that migration. So the key to that was the following five things. First, they needed to become an API first business. So every single microservice that was built needed to be fully atomic, fully autonomous, easily discoverable, and easily orchestratable via Kubernetes and containerization. And so essentially, when they were building the microservices, they needed to build an API catalog of all the key business services that they could embed in any of their internal or external applications. Okay. And as we talked about, every single one of these services needed to be fully containerized. So even where they had some sort of legacy backend system or application, they needed to put a wrapper around it with some containerized microservices that could encapsulate how that backend legacy business functionality was called or orchestrated. Okay. Also, as we were deploying these containerized services, they needed to have hooks into new frameworks for observability, as well as governance to ensure that you were providing the service level agreement for each of these core business services to any of the applications and experiences that were embedding them. And of course, it's not just about building something once, but it was all about ensuring that there was a pipeline of continuous innovation that could be enabled your DevSecOps pipeline. Now, this was really important because remember back prior to the debut of web application architectural styles, in client server applications, you would have this discontinuous event following some waterfall development process where maybe every 12, 18 months, you kind of update some sort of central client server application. And then we moved to faster release cycles with the debut of web application architecture styles, where, you could basically move to a shorter path, move to more agile methodology where you can maybe update your application every 4 to 6 weeks because it was a little bit more componentized and better encapsulated and more readily deployable at scale. But moving to fully encapsulated, containerized, autonomous business services running in a Kubernetes container, suddenly you can have individual product teams, each owning a containerized service, and then each individual product team could have a very fast release cycle because the dependencies um, between individual services was so well defined because everything was so well encapsulated that you can actually start moving to a continuous release cycle because every single product team could be in a 2 week sprint, and you could have 100 services that you're building and deploying and enabling through your enterprise API catalog, and everyone could be moving at different speeds. So you have this continuous pipeline of innovation. And of course, at the end of the pipeline, how did you roll out and scale the application? Well, it was all through declarative infrastructure. You didn't necessarily have someone physically standing up servers or spinning up EC2 instances. You basically leveraged technologies like Terraform and just automated the deployment of all of that core infrastructure. And of course, this is where we all are today. There's nothing unique or, surprising about this. This is the best. This is best in class. This is what we've done in the end of the past 10-year cycle. Leverage all your containerized, business logic that you build or you fetch from something like GitHub, and then run it through your pipeline, and then ultimately leveraging declarative infrastructure. Spin up all of your either virtual machines, bare metal machines, the core CPU infrastructure from an AMD or an Intel with all the associated storage, database, managed Kubernetes, networking resources, so on and so forth. And then, of course, you pushed all of your functions as close to the edge as possible, as well as all of your content through all your caching. So this is kind of the where we are with modern CPU-centric compute architectures in the cloud. This is what you get from traditional hyperscalers, Oracle, Amazon, Google. This is also what you get uniquely from the only global independent cloud that provides the services of hyperscaler, Vultr. Now, in the Vultr case, while you have the same core cloud native platform as you do with the traditional three big hyperscalers, you also, we'll talk a little bit about this, also have it at a massive performance advantage and a significantly lower cost profile to more readily scale your business operations without hyperscaling your cloud compute costs. Those costed performance advantages can be anywhere between 50 and 90%. And we'll talk a little bit about that in the end. So now, as we're extending into the new era of cloud compute, we've got to take these core principles of cloud native engineering and we've got to factor them in into our new way of thinking, because the new way of thinking cannot just be get any GPU you need and put it in any data center where you can get the capacity, and then that is the centralized monolithic model that you're going to build all your applications on. That doesn't work, right? That's why here at Vultr, we're pioneering the global availability of any GPU at any scale in any data center location, so that if you need top of the line NVIDIA H200s in Tel Aviv for training a model, and then you need access to top of the line NVIDIA GH200 GPUs across 32 data center regions worldwide, so that the models that you build and train in Tel Aviv, you can actually deploy and scale globally. You need to have that infrastructure flexibility. So just like with CPUs, you can spin up CPUs anywhere you want. You should be able to spin up GPUs on demand anywhere you want as well. Which means that you need to have, again, those same core principles of cloud native engineering, which is As opposed to having an API catalog just for your core business services, you need to have an API catalog for your core inference services. As opposed to just having containers for your application code, you need to have containerized models, either that you build yourself or that you fetch for some, you know, public registry, like a Hugging Face. Um, just like you can have observability into the performance availability of your application code with a built-in compliance framework about how that application code is delivered and meets, your terms of service. So too, do you need to have that for all of your AI inference services, um, with one step more with the compliance framework extending down into the underlying data layer so that you can establish the provenance of the data and all of the compliance around the utilization of your data. And we'll dig a little more into that as well. Your DevSecOps pipeline needs to be extended for AI ops. And very importantly, especially for us here at Vultr, is you can't forget that you have to have the declarative infrastructure. So just like you can spin up CPUs, why can't you just extend your Terraform template and automatically spin up whatever GPU you want anywhere you want in the world? So there's the new model, which is actually the old model, but just applied now to GPUs and to containerized AI services, inference services, right? So this shouldn't be a radical, mind-blowing, my God, like this is so radical. No, it's actually exactly what we already do. We just haven't thought through the process of like, well, now I need to do this for all of our new AI services as well. Like, why can't I just pull something from a public registry, pull it into an on-demand training cluster, and then move that trained model and then move it to another on-demand training cluster where I can marshal data that needs to be resident in a specific region and do some fine tuning, and then automatically spin up all over the world all of my GPU infrastructure to deliver it. Now, what's a little more radical is what we're pioneering at Vultr, which is you need the best of both worlds, which is you need to have one integrated pipeline for your containerized AI models and your containerized business services. And you need to have like one single infrastructure as a code template that can spin up everything anywhere in the world that you need, because you're still having an end experience and end application that's actually going to call these inference servers to deliver, something of value to your employees and to your customers. And so what we believe is at the end of the day, just like you can spin up any Intel or AMD CPU along with all these associated compute infrastructure to deliver all of their containerized business applications and scale them up and down on Kubernetes natively, well, that same infrastructure as a code template should also be spinning up any of your AMD and NVIDIA GPUs for both training and inference, and then scaling up and scaling down the inference models on via Kubernetes. Oh, and wait, let's also not forget the latter half of the cloud native, revolution, which is everything needs to get pushed to the edge. So you can basically have global CDN, caching of code, content, and models, and you could also have serverless foundation for that. So I could just write a function and go, or I could just deploy a model and go and just have the scaling just happen auto-magically. Um, so this also takes us to our next tenet of what a hybrid, and this is essentially the composability revolution, which is let's bring the tenets of containerized business logic and, you know, inference logic, and let's make sure that those containerized services and models are readily orchestratable through core infrastructure as a code template to alleviate the burden on IT ops for building and scaling compute infrastructure. Everything should just happen as part of an automated pipeline of continuous innovation and delivery. But that pipeline is indeed dependent upon actually having the proper networking architecture so that you can marshal all of your internal data and bring it to your training clusters, bring it to your inference services, and hook it into any set of cloud services coming from any third party or third party cloud. So when you look at this future foundation, this is not an all in one and done platform. It's a multi-cloud platform. It is a hybrid cloud platform. And this is critical because in the early days of cloud compute, just because of the nature of the way the cloud compute market developed, people natively built on Amazon and then later they natively built on Azure. And there really wasn't this concept of interoperability between cloud providers and between cloud services. And again, some of that was just because of the way the staggered debut of different cloud platforms in the early market that things wound up essentially getting you locked in to a certain path of development and application hosting. Well, in this new era, we need to avoid all of that lock-in, and we have to remember that compute resources are just fungible resources, and Kubernetes and containerization needs to be that abstraction layer, and then what's happening underneath that containerization layer should be just plug and play infrastructure services that are coming from any one of us. So your ideal future is a combination of leveraging a global independent cloud, we believe, a little bit of self-promotion, I am in marketing, Vultr with an OCI, with an Amazon, so you can leverage innovation in their core cloud services and then leverage the core compute fabric that delivers the best cost of performance globally with someone like a Vultr. And it's key here is this is why here at Vultr, we, manage the interconnects for over 900 data centers around the world, growing every single day, making certain that you can have one secure, trusted hybrid cloud, deployment. So again, you can take all of your proprietary confidential information, securely bring it to your, GPU training clusters, and again, safely, securely deploy that application globally. We'll talk a little bit more about data ops in the context of serverless delivery in just a moment. So speaking of serverless, as we've all seen, in the early rush to build and train new models, um, what do you do with those models, once they're actually complete? And what we've started to see is initial companies, building and deploying, finalized applications, starting to leverage their training cluster for inference. And, just even on the Vultr platform, we're seeing people starting to leverage up to like 40% of their training capacity for inference. And we just did a worldwide survey of over 1,000, AI leaders, and as they're looking to deploy, production models at scale already in 2024 at the latter half, that's exactly what we found. Roughly 40% of training capacity is actually now being used inference. Now, obviously, that's not the right approach because the performance characteristics of what you need in terms of your GPU architecture for training, for fast training, is very, very different than what you need for the architecture for delivering inference. So on the inference side, you need to tightly couple your CPU plus your GPU with shared memory. You also want to have a much more distributed architecture for that because obviously you're going to be inferring the model in different locations around the globe to support your global employee and customer base, right? You're not just going to do everything in a monolithic centralized location. So again, we have to take lessons learned from both the web application revolution as well as the cloud revolution to basically say at the end of the day, you should have a worldwide global inference fabric so that wherever someone is hitting, your core digital service, whether they're in Miami or whether they're in Delhi, they're getting basically routed to the nearest available inference cluster for purposes of servicing that request. And so what we here at Vultr do is we extend core principles of serverless compute platforms now to this day and age of AI, which is at the end of the day, leveraging our global inference fabric depending on where you are and what the application is and what is the model characteristics, will automatically route you to the nearest inference cluster. And most importantly, depending on, again, the characteristics of the application and model, and depending on the GPU availability, the type of the GPU configuration, the GPU memory, automatically, start scaling you up and scaling you down on the best performant GPU. That might be an NVIDIA GH200 GPU. That might be an AMD MI300X GPU. At the end of the day, you shouldn't care. Now, in the days of in servers compute world, do your application developers, when they're throwing a function, they just know they're just throwing a function into Lambda on Amazon, and they don't necessarily know what's the CPU is underneath that, nor do they care. They shouldn't care. So long as you're getting the performance characteristics and the cost profile, that's what's really important, right? If you're a data scientist, I would argue it's even more important to have that abstraction layer, because if you're a data scientist, the last thing you know or care about is, data ops pipelines, IT ops pipelines. That's just not your world. You're sitting in, your Jupyter notebook, you're slinging Python code. You just want to basically run your code and go. And especially in this day and age of GPUs where you have very rapid product cycles and lots of changing specifications at the network layer, at the CUDA layer, it's just too complicated. So at the end of the day, let the cloud provider worry about that. Sling your Python code in your Jupyter notebook and just let it run, and let us manage an SLA that's best matched to your cost profile. And then we'll determine, what GPUs need to be spun up in what locations to start scaling your application. Now, this also says, well, if you're going to do that on the serverless side, well, don't forget about, RAG, which is the ability for you to take all of your data, safely extract, transform, and load it into a vector database so that you can start leveraging that context to deliver a very hyper-personalized experience. And so this is a very large archetype, and I apologize for that, but the future is about a serverless architecture that puts RAG at the core, so that every single time when you create that hybrid cloud platform and you directly connect something like a Vultr with your internal, internal data data center, that you can implement, a managed Kafka for real-time updates from your enterprise service bus to automatically run real-time updates through Kafka through an embedding service like the Vultr embedding service to real-time populate your vector database, so that as you're getting all the incoming requests and they're hitting the serverless API, it's being front-ended by the RAG database so that those context is being appropriately handled. Oh, and that worldwide serverless compute foundation is married in each region to a worldwide compute serverless foundation powered by AMD CPUs to basically deliver all of your applications globally at scale in a safe and secure way with an integrated pipeline, not only of containerized business applications and containerized inference models, but as well pipeline of data and real-time data updates. So in key verticals like manufacturing or healthcare, the incoming data from, maybe IoT devices in a healthcare clinic or IoT devices out in your manufacturing plant, all of the data real time is getting transformed and safely, securely loaded in the vector database so that it has the appropriate response for your clinician in the clinic or your field service worker in the manufacturing plant. This is what we believe, this picture, which we would love to explore, in more detail with any one of you, we believe is the core architecture, I mean, marketing of the next 10 years of core cloud compute. And of course, at the end of the day, we have to put compliance and trust at the safety and security of the mission. Here at Vultr, we launched our platform in 2014. Trust and safety compliance was at the core of the mission from day one. And for an independent cloud, we're proud to have the compliance posture of the big, uh, the big hyperscalers, the Oracles, the AWS. So you can leverage an independent cloud that has the better performance and cost perspective with trust and safety, specifically for AI built in the core. And so this is what we believe is the modern approach to new AI native cloud infrastructure. And here Vulture, again, we're so proud to support the Israeli tech ecosystem, proud to be the first global independent to open our data center in Tel Aviv, proud to be the first cloud platform to provide global availability for top-of-the-line NVIDIA GPUs in Tel Aviv. Also proud to now be the first cloud provider to offer top-of-the-line access to AMD GPUs in Tel Aviv. And we couldn't be more proud to continue the support of the Israeli tech ecosystem, not only with this event, but with upcoming events that we're running in conjunction with Calculus to support the Israeli tech ecosystem and some of the ties to the Israeli tech ecosystems with ecosystems throughout Europe and upcoming here in Miami this November.